Welcome to the session of Engineering Mechanics. In this session, we are going to discuss about the polygonal law of forces. We'll discuss on the understanding of the polygon law of forces, how to construct the force polygons, and how to apply and find the resultant forces, and finally we'll solve a numerical problem in a graphical method. First, with the explanation of the polygon law of forces. The statics and dynamics study includes the fundamental concept in the field of mechanics, and particularly the Polygon law of forces becomes the fundamental concept. Based on the polygonal law of forces, the resultant of multiple forces acting on a body can be calculated based on the polygonal law of forces. This principle is essential in understanding how different forces interact and combine to produce a single resultant force, which can then be analyzed to determine the overall effect on the object in question. So this polygonal law of forces can be stated based on the concurrent force and coplanar force. First, we will understand what is concurrent force and coplanar forces. In concurrent force, the forces in the forces system is said to be concurrent if the lines of all the forces intersect at a common point. It can be observed from the diagram. And in coplanar forces, a force of system is said to be coplanar if the lines of action of all the forces lie in one plane. So this discusses the concurrent forces and the coplanar forces. Moving on with the statement of the polygonal law of forces. Here, a number of coplanar forces are acting simultaneously on a body which is represented with a magnitude and direction. All the forces will have both direction and magnitude. So this magnitude and direction is represented by the sides of a polygon which are taken in a particular order and then represented graphically, and the final closing side of the polygon represents the resultant of the entire forces. So as discussed earlier, we have the system of forces acting on a single body which will be represented in their own magnitude and direction. The final resultant will be taken, or the final effect of the all the forces put together will be taken as the resultant of the forces. So this is explained here. So let us assume this is a coplanar, the concurrent forces. All the forces are acting at one single point, and there are four forces represented along with the magnitude and the direction F1, F2, F3 and F4. So when we are drawing the representation of the direction and the magnitude in the resolution form, the F1 is the force, F1 force vector in its magnitude F1, and the direction is given over here. A parallel line will be drawn to represent the F1, and F2 is the force F2, F3 represents the force F3 along with its magnitude and direction, and F4 along with its magnitude and direction. So this F1, F2, F3 and F4 are all the concurrent forces which are represented in this particular system of force. This system is not in equilibrium because it is still open, and once the system is closed, only then the forces will be in equilibrium. So this equilibrium can be obtained when we are representing the closed side of the polygon in the opposite direction of the force. So F1, F2, F3 and F4 are moving in the clockwise direction, and the resultant force R is represented by closing the polygon in the opposite direction, that is in the anti-clockwise direction. So the polygon, if it is still open, the forces will not be in equilibrium. So for the polygon law of forces, geometric approach can be obtained when there are two or more forces are present in the system. If two forces are available, then the system, when it is closing, it will become a triangle law of force. If more than two forces are available in the system, then it becomes a polygon law of forces. So there are two methods in which the resultant force R can be calculated. That is either by the analytical method or by graphical method. In this session, we will see a graphical method problem. So the conditions of equilibrium is if the polygon closes, the system is in equilibrium, and if the polygon is not closed, the closing side will be the resultant actually, but if it is not in equilibrium, the resultant force cannot be obtained. So we have to find the checking of the forces which are in balance. So with the numerical problem we have here, the following forces act at a point. We have 20 Newton inclined at 30 degrees towards the northeast. Second force 25 Newton towards north, 30 Newton towards the northwest, and 35 Newton inclined at 40 degree towards the south of west. So these are the system of forces given. We are representing the system of forces in a graphical way. We are indicating it along the northeast, west and south direction. So we have the first system 20 north inclined at 30 degrees. So that will be represented by the force P. The second force 25 Newton along the north, that is represented by Q, and we have 30 Newton R and the 35 Newton which is represented along the southwest. So here we have the four set of forces acting at the system. This can be represented as a vector diagram. The magnitude of the force can be represented like starting from the PQ. We have, this will be the PQ system. The PQ system is represented here with the 20 magnitude represented in some scale at an angle of 30 degree, and then QR represents the 25 Newton towards the north. So QR is represented parallel to the QR, and then similarly the 30 Newton and then the 35 Newton. Now this system is not a closed system. The final closing side of the polygon represents the resultant of the entire force. So the same is explained here. We have to select some suitable point P and draw the PQ with the first set of force 20 Newton at 30 degree, and then the second set of force 25 Newton, the third set 30 Newton, fourth set 35 Newton. So when we join all these things, the polygon will not close. The closing side of the polygon becomes the resultant force. So this closing side can be measured, and based on the suitable scale what we have selected, we can calculate the magnitude of the resultant force, and the direction will be calculated based on the angle from the diagram. So the applications of the polygonal law are, we can calculate the resultant forces acting on the crane and cable supports, the bridge trusses, the forces can be resolved, the suspension systems, and in the structural analysis of the beams and frames. The useful part of the polygonal law of forces is that we are finding a method to determine the resultant of the multiple forces acting in a system, and it applies to coplanar force systems also. And it is important that in statics and in the determination of analysis of forces in the structural systems, the polygonal law of forces holds good. Thank you.